Okay, so my clock says that it's 2:01, so I'm going to start the session because, yeah, as I mentioned earlier, we have quite a packed agenda. For those of you who don't know me, my name is Gergana Petrova. I work for the RIPE NCC. This is the academic NREN session that is happening parallel to RIPE 82. Just to let you know, this session is recorded. If we go a little bit over time and you don't have time to stay, you'll be able to watch the recording afterwards. So before I introduce the first speaker, I'd like to give the floor to Maria Hall. She is our executive board member who's going to welcome the attendees.
Yeah, thank you very much, Gergana, and welcome everybody, and very good to see you. This academia session, NREN session, has become a little bit of a tradition since quite a few years back, actually. So I'm very happy that we continue to have these meetings. And of course, these meetings are also open for everybody who's interested in a very exciting thing that is happening in all the presentation that you're going to have. I am also, besides the executive board member, the RIPE NCC executive board member, I'm also manager for the Swedish National Academia Network, SUNET. So that's another reason why I've been extra interested in this session, and I'm happy that we continue to have them. So I will not take so much time, just welcome everybody, and I'm looking forward to listening to all of you. Thank you very much.
Start with the presentations. The first one is from Randy Bush. He's going to talk about the Global Research and Education Network, GREN. Randy.
Hi, hear me? Yeah, I should.
Yeah.
So we talk about the NRENs, and I do research, mostly security and routing and so forth, measurement. But I want to go up a level and how we do measurement on the internet. And so what did I mean by GREN? Oops, the slide is going to advance, please. There we go. It's the Global Research and Education Network. This phrase was coined by Tim Griffin a decade or so back. And it's the interconnected network of the research networks, such as I2, Norgenet, Dante, WIDE. This is not the commercial internet. And the reason I stress this is because, as Tim showed back a decade ago, a series of 3 papers, this is the last one, is that measurements, some kinds of measurements, and of course different measurements are all different in terms of quality and what they're measuring, but showed specific differences between connectivity over the GREN and connectivity over the commercial internet. At that point, he was using Planet Lab, for those who remember it, and they represent measurements of the GREN characteristics. And we just need to keep this in mind today when measuring between universities, labs, or even from a university or lab to the global internet, is make sure you know what you're measuring and that the inferences are supportable. And to go a little further down this tunnel of the know what you're measuring and know what those artifacts you're publishing along with your paper is, please annotate the data. How was it measured? What's the resolution, precision, etc.? When were measurements skipped because your internet broke, right? When were the measurements taken? All the classical things that, for instance, I think it was Verne did a really nice paper on how to rigorously document your data collection. Okay. RIPE Atlas is amazing. I bet you half of the people here at least use it, but it only measures the data plane, which is very frustrating because I do a lot of work on the control plane, measuring routing protocols mostly. I also measure the data plane. And what's interesting is the interaction between the data plane and the control plane can be quite surprising. And the first keynote at PAM 2001 by Crystal Pelser compared traceroute to BGP and showed they tell very different stories. Okay, so assuming that one tells you about the other is not as safe as I like to think before breakfast. I have a dream that Atlas and NREN nodes have BGP and IGP so that I have the data plane measurements connected to the control plane measurements. As it is, I have to do research and measurement to find, risks, vantage points which have co-located Atlas nodes, for instance. All very painful, and you don't end up with very many of them. And then there's the management plane, which no one measures. Okay, and so there's a fair bit of opportunity there for your next IMC paper. I also want to hit on an argument that's been rising higher and higher in the community. And in fact, Ethan Katzbasket and I just had a public fight about ethics. And there are just recent things that are important is, of course, PII for all living things or not. The University of Minnesota conducted a security experiment committing bugs to a public repository. And this was, really stupid. There were researchers who injected BGP that broke significant pieces of the internet. And they said, and it was correct BGP, but the routers had bugs. And they came back 2 weeks later and did it again, saying, well, the router should have been fixed by now. This is insane. The real operators take many months to verify new versions in the lab before deploying. And there was one now famous researcher who kept breaking the IETF network with perfectly protocol correct, but there was a weak machine. Asked him to stop. He said yes, but his thesis advisor says go to hell. So I just pulled the Ethernet. The thesis advisor hasn't spoken to me since, which I think is a feature, not a bug. The researcher has become famous. Once it leaves the NREN, it's not our network anymore. It's now the real commercial internet. And we're responsible for behaving as members of society. We're guests now. We used to be the whole internet. Now we're guests on the internet. And we should behave like reasonable guests. Wear a mask, keep socially distant. The end.
Thank you, Randy. Are there any questions for Randy? I see that there are some messages in the chat. Daniel saying, RIPE Atlas is intended to measure only the data plane. It was designed at a time that most work was done on control plane data.
Never mind, it was just background stuff. Don't lose time reading that.
Okay.
Yeah, for historical note, by the way, I have to confess that I had grave doubts about Atlas as it was starting. saying, what's the experiment you're going to conduct? And Daniel said, it's infrastructure for experiments. And I said, that's not science, that's operations. And now how many of us use Atlas?
To which I responded at the time, the RAP NCC is about operations in that area.
Well, I don't see any raised hands.
What is the management plane? SNMP and the stuff to measure, the operational stuff that operators use to measure their deployment or to configure and control it. So for instance, measuring different flavors of what's currently popularly called SDN, et cetera. I don't think anybody was saying that Atlas isn't awesome, Shane, unless you wish to take that position.
All right, so I see some more messages in the chat. But if there are no questions for Andy, then thank you very much for the presentation. And I'm going to move to the next one. It's Martino Trevisan, who is going to talk about realistic emulation of radio access networks. Martino, the floor is yours.
Thank you. Okay, let me share the screen. Okay. Okay, can you see it?
Yeah.
Okay. Okay, good afternoon, everybody. First of all, thank you, Gorgana, for inviting me and also organizing the session. Today, I want to present you our work called NREN, which is a realistic emulator of radio access networks. This work has been done and published in a paper that you can find here, and is also an open source project that you can find on GitHub. As the title suggests, NREN is a realistic, meaning data-driven emulator of radio access network. This means that it is based on real measurements that we've taken. The motivation of our work was basically this. If you take the standard and popular tools or browsers like Google Chrome and others, maybe you get some features to make traffic shaping, and you typically have some presets. Like here in Google Chrome, you have regular 3G, and they say that it is 750 kilobit in download, 250 in upload, and 100 millisecond delay. But actually, these presets are there, and we don't know how they build them. And this, for example, if you take other tools here, Chrome, web page test and browser time, or also some emulators like Android, they have other presets, but you don't know basically how these presets were built, and they also have different values. So we decided to go for a data-driven emulator. We were lucky, we had the Monroe platform at our disposal. The Monroe platform is based on the Monroe European project. It is something rather similar to Planet Lab that was mentioned before, but composed on mobile modules. So
something happened. I'm not sure if I'm the only one. I don't hear anymore.
No, you're not the only one.
Not the only one.
No.
You.
And let me just quickly chat to him.
I think he disappeared. Yeah, exactly. The wireless emulation is too realistic.
Right. Well, in
I
this,
would move to the next talk and see whether you can rescue him later.
yeah. So let's move indeed to the next talk. Kevin Limonier, mapping the routes of the internet for geopolitics. Kevin, are you here? I see that you're here.
Can you hear me?
Yes, we hear you now.
Have you lost a lot?
Hello.
Sorry,
I'm
there is.
sorry, I think I have a problem with my.
Oh, I just hear that Martino is back.
Yes, sorry. There is actually a storm now in my city, and so maybe the internet is not so good. Okay.
Okay, please go on with the talk if you think it's fine, or.
Yes.
All right.
Okay. Sorry.
No problem.
I think it was in the slide. Gorgana, stop me if something goes wrong, but I was saying that we use the Moro platform, which is CAT-RED, around 6 countries, 27 mobile operators, and some colleagues of us use this infrastructure to make a large-scale measurement campaign using these nodes. They made 100,000 speed tests, probing the downlink, uplink, and latency of this mobile network, and also collecting the metadata like operator, signal strength, and radio access technology. And the results show that, yes, the scenario impacts the network conditions, and also there is a lot of variability here. So we said, why don't we use this data to create a data-driven emulator so that we can reproduce these conditions? And that's how our emulator was born. So ERANT is an emulator that takes all this data as input, so speed test that we made, and the network condition under which they were made. And so for each scenario, a scenario is a combination of the country, the operator, the radio access technology. You get a model, and this model estimates the probability distribution of downlink, uplink, and delay. That's how ERANT works. We have one model for each scenario that models the network conditions, and then we use these models to impose new traffic shaping rules on at every moment on the network interface, and the traffic shaping rules are imposed using the standard TC and NTM tools. And I want to be brief, but mention that ERANT is accurate because if we do some real experiment over a real mobile network and some experiment using ERANT, so the green and the red lines, they are more or less the same. This is the download speed of some bulk HTTP download. While if we use a static preset, the blue line, this is very, very static, and we cannot reproduce the variability that is in the real networks and ERANT can reproduce. Also, we used it for some application, also some example application to show why this works. And this is, for example, if you want to test a web page like Wikipedia in this case, you want to understand how fast it loads under mobile networks, you can use ERANT. And if you use a static preset, you get maybe the average value, but not the variability here. And if you use no emulation, clearly the network goes very quickly and the results are very different. So here ERANT can help us in understand how a web page would look like and its download speed on a mobile network. And also another example, possible example, is to use the dynamic streaming over HTTP. Dynamic streaming over HTTP adaptive bitrate. If you use a static preset at some point, the bitrate of the video resolution settles to a value, while if you use ERANT that is able to reproduce the variability of mobile networks, you can get that there are some fluctuations. So you can trigger these behaviors that you would not trigger using a static and simple preset. This is all. Sorry for losing my connection. Okay, so Did you understand what I said? So there was some problem, or it worked?
I think this time we heard you well.
Okay, thank you.
Does anybody have any questions for Martino? Please raise your hand or write it in the chat. I don't see any hands at the moment. I do see a question in the chat. How is the emulation implemented? If you can
yes.
again.
There is also a second question. The emulation is implemented using the TC, NetM tools and all these standard tools. What is actually the smart part is how to impose, which values to impose using TC, NetM, and they are extracted using our models. Then we use TC, NetM. And Arilova, who was asking if it works with 5G. Actually, this is our future work, because also we wondered this. And once we will have some platform to make experiments and speed tests using 5G, we will be able to prepare the models. So we are ready, but we are waiting for the measures.
All right. Thank you. Thank you very much for the presentation, Martino.
Thank you, Gloria.
So let's move to the next presentation. Kevin and Luis, I give you the floor to talk to us about Eastern Ukraine.
Yeah. Hi. Can you hear me this time?
Yes. Yeah.
Okay. And I can hear you. That's great. It's okay. Hello, everybody. Well, thank you, Gargana, for the invitation. That was kind of last minute, because we had this paper that we are going to present today that went out last week. I just wanted to have a very short introduction and presentation of what we do and why we do what we do. Regarding to the audience I'm addressing today, because I'm not, and Louis also is not, we are not computer scientists, or I would say from technical background. We are social scientists, geographers, and we discovered some years ago now what we can do with ripe data, and how we can do it. And that's in that perspective that we want to share our work today with you. Just a few words about the research center upon which we are doing this work. It's the name of the research center is GEOD. It's a research center that has been founded in Paris now 2 years ago by geographers in order to improve and to develop new methodologies for mapping the internet, for mapping cyberspace, but also for understanding the intrication between the physical space and the digital space, as we can say, because what we do as geography basically is studying how people live on the ground, okay? And if we are interested in how people live on the ground, we are interested in how they connect, how they exchange data each other, and how, as geographer, we can bring our small competence to the question of internet mapping, internet routing, and all the wonderful stuff that RIPE NCC is doing for years now. So basically, that's our research topic. We are also an education organization. We have 2 master's degrees, and for example, since last year, I am training my students, social science students, to use RIPE data, for example, on topic like understanding connectivity dynamics in a given region of the world, for example, the Pacific, or for example, Eastern Ukraine, or a given region of France, and how the RIPE data help us to understand how a given region is connected to the rest of the world and why it is connected like that, And for us, it's a very, very valuable set of data that we are trying to implement in social science research fields, even if it's sometimes a little bit complicated because of the fact that, of course, digital space is not comprehended the same way by many of our colleagues in sociology or in geography. So I leave the floor to Louis, who will present the concrete case study we wanted to present today. Thank you.
Okay, hi everyone, thank you. And I'm gonna share my screen. I can, okay. So yeah, we wrote last year and this year 2 articles about, well, let's say connectivity in Eastern Ukraine and in Crimea. Last year was for SciCon and this year for First Monday. So I'm going to present real quick what we do with RIPE data. And you, of course, I hope we have time for some questions later because I'm going to probably be a little quick. So just to make you see the, well, basically what we do is trying to find or trying to bring the interconnections between geography and geopolitics with the internet. And by that we are using, well, this is for instance, an AES graph of the world with a force algorithm layout. And we added geographical data, in this case, basic country. But already you can, if you take some time on this kind of graph, you can find geopolitical constraints that are driving the topology of the network. And what we did was take a specific case of Eastern Ukraine, which is at war right now, between Kiev and separatists in the region with support from Russia. And what we did was first to well, basically send a few trace routes to see what was going on in this region. And we saw that it was possible that we witnessed a form of borderization in the digital world, to put it like that, using, in this case, RIPE atlas measurements. And if we took another point of view in the point of view of routing, using RIPE RIS, among other data sources, again with an algorithmic layout and with countries shown, but then we applied a qualitative fine-grained analysis on, well, let's say metadata, almost OSINT data on the autonomous systems that we were seeing. And we draw what we were seeing, meaning the separation in the digital space at the level of routing of specific regions from their former country, in this case, Ukraine. And of course, at the end of the process, you see the geopolitical consequences, which are major leverages for Russia in these regions that are not controlled theoretically by Russia, and on which Kiev is losing sovereignty. And just as a final slide, I've put some of the internet mapping visualizations that we are trying to, well, explore in a way. So we can go over them later as well, but just to put, well, to make you see what we are trying to do in various ways, always trying to put geography in internet data or the other way around, to try and see what kind of geopolitical constraints act on the network, and vice versa, how the network shapes geopolitical realities on the ground. Okay, I hope I was clear. Thank you.
Thank you very much. Any questions or comments on the presentation? Please raise your hand, or you can also write it in the chat. Daniel, and then Robert.
Yeah. Generally, when you do this kind of stuff, and I find it actually fascinating. I'm going to look up your papers. I hope we get some references there. Is there any way we could improve the tools that we provide for your specific kind of work? Do you have a wish list?
I'm not sure actually, because just to put it more clearly, maybe we are working with computer scientists and mathematicians that help us on things that we do not know or that we sometimes have a hard time understanding. At that time, I think most of the things that we would need would be on their part to do. Maybe right atlas, we could have some ideas, but I don't know if Kevin has some. But
Sorry?
Thank
I
you.
don't know if you have some ideas for that question. But
Yeah, I have. Yes, I have, especially regarding education. Not especially research, because as Louis said, we have engineers and computer scientists to help us with the complicated tasks. But regarding education, I think there is something to do with students interested in understanding the geography of a given country, of a given region of the world. So how people, go from one point to another, etc. But we could definitely propose a kind of more, I would say, friendly interface or something like this for people not, I would say, not very comfortable with technical issues, even if the interface is already quite simple and very user-friendly, according to me. But for example, when you do some RIPE atlas measurements, for the students, we have to put the IDs of the probes on how do you say it in English? On a geographical information system in order to extract the data, and there is a kind of a bit of tricky operation for social science students. But a part of that, we have everything we need for the moment. But I'll I keep thinking about it.
Thank you. Robert?
Yeah, just a quick note. Referring back to what Randy said at the very beginning, I think this was a really good mixture of data plane and control plane visualizations and data. So I loved it. Thank you for it.
Thanks, Robert. I see there's also a question in the chat. How do you map hops nodes to geolocation? Did you rely on the data given by RIPE Atlas?
Louis, do you want to answer this tricky question?
Well, actually, we use, again, we work with our colleagues, but we use a variety of other kinds of data. And we try to use first geolocation, IP geolocation data, which is not specifically reliable depending on the, where you find source. And our colleagues are developing currently methods to improve that. And then we also have to look at the, cables data. And this is a qualitative only work. We can only go a little bit by little bits with our knowledge and by researching all of the infrastructures that we know of and that we could think of. So when I showed this map, it's, let's say, a potential map and maybe the most likely way that data are going to. We don't have, we would, of course, love, but I'm sure we're not the only ones, to have this possibility to map automatically IPs with locations. But right now we are just assuming what we can and then using data on autonomous systems with other kind of maps to confirm or the opposites, what we think we have found.
Just as a complement, we are in a kind of perpetual cross-validation of geolocation operations with our computer scientist colleague, because they have algorithms, they have their own methods in order to have more precise location of IPs, of whatever you want. And then our job is to cross-check what they have found with the qualitative knowledge we have of a very specific area, if something makes sense doesn't make sense because there is no cable on in that place, because this IXP doesn't work anymore for whatever reason. So we are trying to yes, to have this double check methodology, which is quantitative, of course, and thanks to RIPE, but also qualitative. There are other questions. To what extent the territorialization matches the geopolitical borders? That's the $1 million question we are trying to answer. How a border which exists in the physical world, well, not in the physical world, but in the human representation of the physical world, how the border exists or does not exist in, for example, routing protocol layers of these kind of things. And that's why we are studying countries like Russia, where they are implementing now, you know, this sovereign internet law, RUNET, sovereign RUNET, they call it, and where they want to be able to filtrate the data traffic according to diverse point of the network. And what they have in mind is to implement a kind of digital border here, but we see that it's not so easy. So that's a very, very tricky question. And if one day we have an answer to that, well, it would be wonderful.
Any other questions?
I've seen one about, thank you, Robert, for your solution, ipmap.ripe.net, which I don't think I've looked at yet. We'll definitely do that later. And yes, if you map internet connectivity to physical routes, isn't there a danger you're showing where to strike? Well, the idea is that physical routes are not yet mapped by us. We again are also trying to work on that. Well, not Kevin and I, but our colleague. So yes, it's very sensitive and strategic data, but we will, when we have specifically physical routes, we will not map them as obviously as we map routing or such. We will be careful depending on what we are looking at. But you can already, I think the only good map currently, well, the only one I've seen is from the ITU, and so you have already some maps with physical routes, but and also I think many services around the world know a lot about physical routes before us, so we'll see where that leads us.
All right. Farzaneh says, if you can measure digital territorialization with this method, that would be fascinating. And
that's what we are trying to do.
Petra is asking, are you also seeing effects from physical boundaries like large rivers?
Yes, we are, especially in regions like we conducted one of the first measurements I conducted with RIPE data. It was maybe 4 or 5 years ago, maybe more. Was about mapping latencies in the Caucasus, and Caucasus mountain were clearly visible as a kind of obstacle, but it's not sufficient to explain because it was after, well, there is no cables going north from south of the Caucasus except one, which it may be cut at the moment because of the geopolitical tensions between Russia and Georgia. But yes, you can see some kind of geographical, well, physical obstacles like mountains, rivers, oceans, and whatever.
All right, thank you.
Thank you.
So
thank you.
Thank you very much for the presentation. Let's move on to the next one. Edlira Kalemi is going to talk about semantic digital twins.
Hi, everyone. Do you see the screen?
Yes. Yeah, we see it.
I am Edlira Kalemi. I am a lecturer of computer science at Birmingham City University. The presentation today is a work conducted under an Innovate UK project in UK, together with other colleagues. It is a multidisciplinary project. It applies semantic web technologies in the construction domain, and more specifically in the industrialized construction. In many countries, this type of construction is named differently. Industrialized construction is a typical name used in Europe. In UK, we usually use off-site construction. And if I can give you a little bit of background of what it is about, or another name about it is prefabricated. And we are talking about a scenario where we have to construct houses, and then the construction of the house is not a typical construction that is being held on site, but the components of the house are constructed in a factory, and then they are transported in place. That's why it is called industrialized. And in this context, the more specific approach that we have been working on is what is called the DFMA approach, which is design for manufacturing and assembly. The domain is very advanced in terms of technologies, and they use a BIM model that is called, where they collect all the information, they design the project in these scenarios, the houses, then the houses are manufactured, and then they are assembled on site. Now, what does this all have to do with computer science? The whole process in many cases is automated, so a lot of data are interacting out there, and for us as a partner, the main thing was to make an estimation about the cost, CO2 emissions of constructing these houses, and to design a knowledge-based engineering tool that will help these engineers, these architects, in doing these predictions, these estimations before deciding to move into construction, or before deciding to develop these manufacturing environments to produce a massive amount of houses. This method of construction is mainly seen to have a lot of advantages, not only towards the cost, and that is one of the KPIs that needs to be measured, but also in a sustainable economy, in a sustainable society, and measuring the CO2 emissions is also a crucial aspect. On the other side, the problem needs a lot of data, and the data are very heterogeneous and are coming from different sources. One source of information is coming, as I mentioned, from the BIM model, where there are geometry information, material quantities. Another source of information may be the relational databases with the prices of different products that need to be used. Other source of information is the ERP of the company, where we get the information about the resources that will be engaged in these projects, like labor, pay rate for the labor. Then other information that might be related to the supply chain of these products, starting from the manufacturing to the site. And having this scenario with heterogeneous data coming from different data sources, then we decided to use the semantic web technologies that are known for better solving this kind of technologies. And therefore, we started by deciding an initial limitation on the boundary of situations that we will consider to model in this knowledge base, and then we went for designing an ontology about these scenarios. Of course, we did a review of existing ontologies, and there are many ontologies out there that can be reused, like the building topology ontology. There is IFC ontology that is an open standard ontology that can be used, but the offsite manufacturing is innovative. It brings together construction and manufacturing, and we were not able to find a dedicated ontology that can model or can map the knowledge required to perform these processes. One aspect of the ontology would cover the costing part, and the other part of the ontology would cover the CO2 emissions knowledge. Therefore, we implemented an ontology called the offsite construction for houses ontology, and we called it OHO ontology. The ontology is designed in a way to be modular, in the sense that we have a core module that semantically and in a machine readable describes a house, and then associated with it we have other modules like the production module that will represent virtually the production line where the production of pieces is happening. Then we have a module called OHO cost that will perform the cost prediction, and the OHO LCA that will perform the life cycle assessment or CO2 emissions estimation. In this presentation, I wanted to focus on the production line, which is the component called OHO production. This generates what we call it a semantic representation of the production line. A production line is composed of different stations, and different activities happen in each station. They are very specific to the domain, and I will not go through those, but everything is virtually represented in the system. And then all that information is used for performing our other estimations that we need about cost and CO2. The system is designed in a form that is intelligent, in the sense that by initially giving the method of production, and they have different methods of production like manual, semi-automatic, or fully automatic, then the production line is composed and is assigned the connection between each station and how the time and cost will be collected with each other. This virtual representation is also used, or can also be used, for quality checking. These are again details of the ontology. These are some screenshots taken from the ontology and how cost estimations has been performed based on an activity-based method costing that we have used. The basic semantic model has been developed in Protégé, but then after that we have developed what we call a knowledge-based engineering tool using this knowledge and information. If we follow the link, there is an online tool that architects, engineers, manufacturers can use to perform these estimations. As I mentioned before, the system gets different inputs and then performs some predictions and estimation. For the knowledge base that we have developed, and many data are there, we have also provided a Sparkle endpoint where the professionals can directly run Sparkle queries from this knowledge base. And somehow this is the architecture of the tool, where by processing and mapping all the knowledge that we are collecting from different sources in our ontology, further we can perform some inferences or even information retrieval, and then provide some visualization about the knowledge that we have in these systems. These are different screenshots from the tool, the details that we give about these KPIs based on different filtering that the user will perform. And of course, from the whole project and from this work, some outputs have been generating. Of course, apart from giving value to this method of production that is expected to solve many issues in different countries in respect to housing associations, sustainable economy, and so on, this is also a contribution towards the Industry 4.0 that every industry is aiming. I hope I was clear. The domain is challenging. It's very wide. Personally, I am a computer scientist, so I hope I was clear, and I'm happy to answer to any question. I cannot hear you. You are muted.
I was just saying thank you for the presentation and inviting people if they have any questions. Just to let you know, the last two speakers that we had from the 9 presentations decided to present next time, which gives us actually a little bit more time for the sessions. We have 3 more presentations. So if you do have any questions, please, we have time for that. You can either raise your hand or write it in the chat. I forgot to mention in the beginning that because some people are messaging me directly, I will upload all the slides on the page of the academic meeting and also upload the videos of the presentation. So you will be able to download the slides after the session if you're interested. Well, I don't see any question at the moment, so thank you for the presentation.
There is a question about CO2.
Oh, yes. How do you collect CO2 life cycle emissions?
One source of data is from the BIM file. The BIM file is the model that the designer or the architects designs, and part of the data there is the material. And from the quantity of the materials, we do some calculations by using coefficients, CO2 emission coefficients for each of those materials. And then so there are some mathematical models in place, but the input is the material that we get from the BIM model and the CO2 emissions coefficient that we get from different databases like EcoInvent or CIMAPRO. There are also dedicated databases for CO2 emissions coefficient. Of course, we provide different materials even in the CO2 emissions tool in order to have more sustainable solutions. For example, if you will use timber instead of concrete, of course you will have so many benefits in regards to the CO2 emissions. But in the construction part, the materials is the main source of predicting the CO2 emissions. Of course, then there is another aspect is the transportation, but in this scenario, the transportation is just transporting the pieces that have been produced in a manufacturing environment to the site, because the other process or the whole process is happening in a factory. That's why there is an advantage where we do this kind of construction.
All right, thank you. Any other questions?
Now I notice that there is the word life. Okay, so if we put the word life cycle, I hope I answered the life cycle part, but if you want to give it a real-time context, how do you monitor it all the time, then some sensors are engaged in it that will do the monitoring of the energy consumption, and that source of information is also used, but that is not only throughout the construction, but that is the whole lifetime of building existence. Thank you.
All right, thank you so much for the presentation. Let's move. The next one is from Hazel Murray, password security. Hazel, the floor is yours.
Hi, thanks. Let me just, you should be able to just see my slides there.
Yeah.
Okay, perfect. So I'm going to talk about password security recommendations versus reality. So I'm going to start by talking about password advice, then look at the costs and benefits, and then the reality of the situation, and followed, I'm going to talk about just one particular automation attack. So I started this research by collecting password recommendations given by security specialists, multinational companies, and public bodies. And I then categorized them and discussed them in relation to like the research literature. One of the things we noticed was the amount of contradictions in the advice. So to highlight this, I'm just showing you 4 different advice categories. And under each advice category, we're looking at some specific advice statements. So for example, never reuse a password. 6 places said never reuse a password, but 5 places said it's okay to reuse a password. And we've all the purple arrows show where there's contradictions. So for example, don't use published phrases. 2 places said not to use published phrases, and 1 place said, why don't you consider using a quote from a book or a song lyric as your password? And another interesting one here actually is don't use words. So 16 places actually unanimously said don't use words. And yet if we look at anyone's passwords, like people use words all the time. So clearly it's not very effective, even if it is unanimous. So overall, we found that 41% of the recommendations that we collected, if they were given by one source, they were contradicted by another source. So obviously there's no kind of innate way to know what advice is good and what advice is bad. So what we tried to do is actually look at the costs, like the costs of implementing versus the security benefits for each piece of advice. So we asked security specialists, system administrators, and end users about the costs that they think are associated with 70 different pieces of advice. And these costs are anything from increased help desk time, need for user education, and the extra time that a user needs because they've forgotten their password. And then we looked at the security benefits, and this is things like, does the advice protect against phishing? Does it protect against password guessing? What attack types does the advice meaningfully protect against? And in this table, I'm just showing 10 of the 70 pieces of advice we looked at, but I just want to draw attention to 2 things. So firstly, as we'd expect, we did find pieces of advice such as monitor and analyze intrusions, which have high benefits, but do obviously come with some costs. But more worryingly, I think, is the advice that we found, such as change your password regularly, which had really low benefits, I think the lowest of any here, and the highest amount of costs. So clearly there's not a good trade-off there. And I want to talk in more detail in the next few slides about why this change your password regularly advice doesn't really work in terms of the actual attack landscape. So this is what you might often see. Your password will expire in 90 days. And what it's trying to protect against is 2 things. Firstly, it's trying to make sure that someone can't guess your password because they get close and then you change it. And it's also trying to protect against if someone gets your password, you've changed it by the time they go to use it, so they don't have indefinite access. And the types of attacks we're looking at when we're talking about passwords and their security is guessing attacks, usually. And there's 2 different types of guessing attacks. The first one is offline guessing. So in order for this to take place, first, the password set has to have been leaked. And you'd hope that they're like hashed and salted or at least encrypted passwords that an attacker then needs to guess. And the second type is online guessing. And this is probably the one we're more familiar with. Someone literally goes into a website, tries different variations of usernames and passwords until they get into an account. And so online guessing, changing your password every 90 days doesn't really protect against it. Realistically, while anyone can do online guessing, we expect there to be some kind of lockout mechanism that after 30 wrong guesses, you're not allowed to make any more. So even though in 90 days your password expires, realistically, an attacker would only be guessing the most common passwords. And if they do get it right, they get in immediately and they'll be able to make a backdoor so that they can get in again. So it's not really an effective policy against what's really happening in online guessing. Offline guessing. So the idea would be offline guessing, someone can use unlimited amount of time, unlimited amount of resources, because they literally have the password file and they can just keep guessing against it. And the hope would be by the time they've guessed your password, you've then changed it. But this doesn't really work because it turns out people make their next password very similar to their previous passwords. So you might probably be familiar with something like password May, password June, password 16, password 17, as you're told to change it. And actually the real problem with password expiry policies is that, well, firstly, it really annoys users, and also it's quite mentally taxing if you have to re-remember a new password every 90 days. So actually, researchers have found that people make weaker passwords if they know they're going to change it. So overall, it's kind of a security loss for the system. And other advice has similar problems in terms of looking at the actual attack space. So for example, we've often heard the advice, don't write your password down. But realistically, if someone's rifling through your notepads, you've probably got bigger issues. And the real attacks that we need to protect against are automated attacks in terms of the general user. So I'm going to just finish off by talking about one particular automated attack that we discovered. So we created a guessing model that can improve guessing with every guess made. And the idea is a password guesser will have a list of potential guesses made up of previous password leaks, dictionaries of words in different languages, and maybe other sources of information. And we came up with a system that can figure out what order to make guesses in by determining the weighting that should be assigned to each source of information. So for example, if an attacker is making guesses and discovers that most users are French speaking, then they'll want to drop all the other language dictionaries and just keep the French dictionary for guessing. And we were able to automate this using reinforcement learning, meaning that the automated guesser will try to make the best possible guess each time. And we first showed that this improves guessing, but we also showed that it can learn private information about the users in a password set. So we can identify the website the passwords were used for and the nationality of the users just based on their passwords. And we can often discover this within just 10 guesses. In particular, we showed that we can identify German users from Irish, Latino, or English-speaking users, and we can identify Irish users from other English-speaking users, which is particularly interesting because Irish people are also English-speaking mostly. And the fact that passwords are so demographic and website specific gives us evidence for why maybe different rules should be employed by different places. So for example, maybe Irish people need to be not allowed to choose the word Dublin as a password, whereas maybe it's not an issue for everyone else. And similarly for website specific terms. So just to summarize, we looked at password advice and found that it's mostly contradictory. It often doesn't represent best practice and security research. And if you want to know kind of what the best practice at the moment is, it's in the NIST documentation on digital identity guidelines. There can be high user costs and low security benefits for some of the advice that's quite popular. And it's important basically to take into account what the attacks are when we're giving advice. And then lastly, we just showed that we can automate attacks and find out individual information about the password set we're guessing, which suggests we should use some kind of tailored block listing techniques. Thank you.
Thank you, Hazel. Any questions on the presentation? Robert?
Yeah, so the good old XKCD horse staple correct blah 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 advice is not applicable anymore because 16 of your 16 sources that said do not use words. Is that deprecated or did I just miss the memo?
No, so this isn't, so I guess the advice we collected basically wasn't good advice is I think the point here. It's, well, not necessarily good advice. It was kind of like random websites that just kind of put out security rules with not maybe much thought. And therefore lots of places, I think what was intended was don't use like a single dictionary word, whereas what was actually said was don't use words. So we also did find that the advice can be misleading because 3 or 4 words strung together seem perfectly fine, whereas maybe one dictionary word isn't.
Thank you.
Thank you. A question from the chat. Did you go through the NIST suggestions? Are there any contradictions there?
So we included the NIST advice in the advice we collected at the time. I think it was just a draft policy, but not much had changed. And yeah, basically the NIST advice caused like, sometimes if there was only one contradiction with the general advice, it was because of the NIST policy. So I think, let me see, think at the, oh yeah, here. So enforce restrictions on characters. So that's when it asks you to include like uppercase, lowercase, symbol, number. 12 places said do that. And the only place that said not to do that was the new NIST advice.
All right, thank you.
Thanks.
Another question, how did you quantify or quantitatively measure the costs versus benefits?
Yeah, that's a really good question. It was not easy, basically. So in this case, we just did it qualitatively. So we basically looked at all the different benefits and we looked at all the different costs, and we just kind of gave a scoring for how many like things it protects against. And this was like the initial work. So one of the things we do stress is that we're kind of just giving an indication here. In terms of actually comparing one piece of advice against another, you really need to take into account context. Like, for example, protecting against like a side channel attack maybe isn't as valuable as protecting against a phishing attack. So you need to weight them differently. And that is something we kind of looked at in our later work, but here it's just kind of a qualitative indication of how many costs versus benefits. And really the only ones that we can take seriously is probably the one like say definitively things about are the ones where there's big gaps. Like if there's small gaps, we're kind of like, you know, take into account context. Yeah.
Thanks. And do you see any benefit of forcing people to regularly change their passwords, even if those passwords are auto-generated and sufficiently long? And that's assuming that the passwords are hashed in the database.
Yeah, generally there isn't actually a point in regular password changes. Realistically, a password change should only need to take place if there's been a compromise. And if you have a system where you don't know whether you've been compromised, maybe there's like bigger issues. So if there's a compromise, absolutely everyone needs to change their passwords. We know there's been a breach, but changing it every 90 days just in case there's been a breach isn't reasonable or a good use of users' time.
Thank you. What are your findings on password length?
Password length, that's good. So in terms of this thing, in terms of who's saying what? Oh, yeah. Okay, so I think quite a lot of places actually said that they recommended enforcing a maximum length. So for example, your password can only be between 12 and 15 characters, which is just like unnecessary, like yeah, which was quite interesting. So we got some contradictions there. The minimum length, I think it was unanimous. Everyone said that you should have a minimum length password. But one thing we did find interesting is that sometimes a website would say one thing but implement another. So for example, one particular company said there's no limit on the number of like characters you're allowed in your password, but if you actually try to enter a password, they only let you enter 20. So sometimes. Yeah.
All right. Thank you so much, Hazel. If you guys have any more questions, please feel free to reach out to the authors directly to the email addresses. You can see this one on the slide. So thank you, Hazel. I'm going to move on to the next presentation now. Actually, before I do that, I wanted to preface it a little bit and maybe share a little bit something on my screen about what is going on with the RACI funding for this year. Let me just quickly share my screen. Oh, sorry, I cannot do that right now. I will do it after Robert's presentation. So Robert, I will give you the floor to talk about some tool and research ideas.
Good, thank you. So hello everyone, I'm Robert. Those of you who don't know me, I'm the lead of the RIPE NCC R&D activities. And what I'm going to present now is not a research outcome. So just for a change, something else. But what it is instead is that the fact that we have so many ideas, but so little time, just like everyone else. But to put that into context, the R&D department in the RIPE NCC is tasked to do a lot of good stuff for the benefit of the community. And in that context, we are making analyses, tools, prototypes, R&D in our definition. And some of these things you may have seen, like RIPE Atlas, RIPE Stat, RIPE IP Map came up in this context today. But other stuff, Country Jedi, RIPE NES, RPKI, Rich Live, and so on and so forth. So we decided that it's good that if we share some of our ideas that we may not even get to ourselves, but others might, or maybe they can write a research paper out of that, then this could be a good benefit for both the RIPE NCC and the community, which the NCC wants to serve. So I published an article, and I will give you a pointer at the end of the presentation, but just highlights of what ideas there are. The first one is a bit more engineering rather than research. It's the RIPE Atlas Anchor auto monitoring. So we would love someone to develop a tool that's probably just a Dockerified set of scripts and tools that if I run around a RIPE Atlas Anchor host, I just plug in my host ID there, and the tool starts collecting data, which is already available in RIPE Atlas itself, and just shows me graphs and maps and warns me if something is wrong with my anchor or my connectivity or someone else's connectivity. The second one is about detecting Atlas probe behavior, which is correlated to other probes. So imagine that a country has a network problem or an AS is disconnected from the internet. We have signals in RIPE Atlas that actually show this. So if all the probes in that particular AS suddenly disappear, but otherwise everything looks okay, then probably there is something wrong with that AS and not with the probes themselves. So this is a bit of a machine learning exercise, how to find this needle in the haystack, if you will. You may have heard that we published RIPE Atlas data in Google BigQuery about half a year or a year ago even. So that data is available, publicly useful for you already if you go there. And what we would like to know is if data can be correlated with other data sets that people have. So for example, routing data or geolocation data or anything else you can lay your hands on, just to see if those data sets match up. And if they do, then what does that mean? And if they don't, then what does that mean? Locality of well-known services. We ask all of our probe hosts to geolocate their probes. And if those probes ask DNS, for example, about what is www.google.com, they get an answer. And we expect that answer to be the same or very similar if the probes are in the same location, topologically speaking, in this context. But is that true? And if it's not true, then why not? Is the geolocation wrong? Is Google wrong? Who knows? Another question is, where are we missing RIPE Atlas probes? We have 11,500 probes out there in about 5 to 10% of the ASs. But is that really a good coverage? For example, if there are 100 or 1,000 ASs hanging off of one transit provider, we are much better off by having probes in that transit provider's network rather than in the 1,000 end users. There's value in both. But in terms of looking at the connectivity, having coverage of that transit provider is preferred. So where are we missing? Which are the ASNs that we should target? Similarly, risk vantage points. What are the networks that we should peer with? Because if we do so, that provides more useful data to the users that we have and to the consumers of risk data. ASN and IP dispersion graphs. Imagine that you have your provider at home. That provider is probably connected to multiple upstream providers, and those are connected to multiple upstream providers. We would love to see a visualization of this dispersion graphs of how much of your traffic, if you can say, is flowing through one versus how many of the paths outgoing are flowing through another. And then finally, we are constantly doing topology measurements in IPv4 and IPv6 space. And we would love to see if those are actually covering what we believe they are covering. So what we do now is we are just targeting random prefixes all over the internet, all of the prefixes that are announced in the routing tables. But is that good enough? Can we enhance that somehow is the question here. So this is just the first set of ideas that we threw out there. If you are interested in any one of these, then I suggest that you read the article and you can contact us. You can always contact me, but for each of these ideas, we have a much better contact person mentioned in the article, so that's preferred. And if you don't remember this URL, you can always go to labs.ripe.net and you will find, I think this is the newest article there, so it's pretty easy to find. Any questions?
Thanks, Robert. A question from Lars: why is having a probe in a provider better than having one in its customer? The customer traffic should travel through the provider and uncover its characteristics too, shouldn't they?
Yeah, so there is benefit in having a probe in someone's home, because then you can measure the connectivity from the home, but there is a different kind of benefit of having it in the provider. And in many cases, the providers don't even know that they have probes in their networks, because their users just plug them in. So it's slightly different, but I think my example is more applicable in the case where covering a particular provider would cover potentially hundreds or thousands of other networks connected to that provider. So in that case, having a handful of probes in the provider's network gives us more benefit than having hundreds of probes in the clients, basically.
Thanks, Robert. Any other questions? I hope I'm
I have a question.
Sure.
Yeah. Well, thank you. Regarding the distribution, or say the installation of Atlas probes, I perfectly understand that you need to have probes on certain logical points and AESs and etc. Would there be any interest from you at RIPE to have a methods for choosing which place you want to connect a probe on, not only on from a topological or a logical point of view, but from a geographical point of view, because that's something we could help with, especially in some areas like for example Central Asia, Russia, or other places like this.
That's always lovely. I know that it's also a bit subjective, but a whole lot of people look at the maps that we produce and say, look, there's this huge area where there are no probes. I want to put probes right there. And it turns out that nobody lives there, so it's not really that useful. So, I really don't want to discount this, but it's certainly true that where we have more topological coverage, that's usually closer to the actual internet users. If you can put probes like in white spots where we do not have them geographically, that's always welcome, especially if it covers another network that we don't have presence in.
One more question. To select a best set of probes, vantage points, or how to select where to deploy more depends on the things you need to measure. For different purposes, there may be different sets of best probe locations. Any hints on the important problems that we need to address with these best sets of monitors?
I think one can write a research paper on just this question. So I don't think I can write this in real time, but I'm happy to think together, or the team is happy to think together with you if you would like to pursue this.
Okay, thank you. Any more questions for Robert? All right, thank you very much, Robert. I've also included the URL of your article in the chat.
And I will leave you the time to introduce your part.
Yeah, I will try to do that now. My computer is having, okay. Now I no longer have the, now it gives me the option to share. I hope you guys can see my screen.
Yes.
This is the bits that I wanted to share about the RACI project funding. So you know that up until now we have been providing funds to academics to come physically and present at the RIPE meeting. We've been reimbursing their flight and accommodation. This year, most of our meetings are going to take place online. So we are wondering what to do with that money. What a wonderful problem to have. So we have a call out for project funding. You can basically suggest any projects that can make use of the data sets that we have and apply for the money. The total amount is 30,000 euros, and we are asking for applications up until 31st of May. So if you click on this button, you'll be taken to a page. First, you have to create a RIPE Access account, and then you fill out the form to apply. Easy and straightforward. Two things to mention: it is limited to universities and research institutions that are based in RIPE NCC service region. However, you do not have to be a member. Do not have to be a member of RIPE NCC to apply for this funding. So this is what I wanted to share. I will include the link in the chat. And for the next presentation, the next speaker is Yoxel Simsek from Middle East Technical University. He has asked me to stream the presentation just in case to avoid any problems with the connection. So I'm going to do that now. He is online, so he will be able to answer the questions after the presentation. I hope you still can see that.
Hello, my name is Göksel, and I'm going to present you our latest work about inbound telemetry through programmable data planes. So this is going to be the outline that I'm going to follow through, and I will spend my majority of time in the introduction, and then I will briefly go over our heuristic algorithm and then results and finish with the conclusion. So let me start with pointing out some of the importance of network monitoring. So with the addition of new devices or new services, this network infrastructure becomes more complex each and every day, and managing them becomes a challenge. And in order to manage them properly, there has to be an efficient network monitoring underneath so that we can provide up-to-date status information as quickly as possible with low overhead to applications that manage the network. So let me continue with the problems that we have observed with legacy telemetry solutions. So in the legacy telemetry solutions, you will observe that a maintainer of the controller will fetch information from every single individual switch periodically. And this period is kind of a low period due to the high communication overhead between the control applications and the switches. Of course, with the introduction of software-defined networks and the improvements on the open flow switches, these limitations are kind of lifted, as the switches can now periodically send information back to the controller. However, the information that's going to be collected is not customizable enough in the switches, in a sense that you cannot introduce your customized protocols or customized telemetry pool freely. And addressing these limitations, there's a new concept called P4, which is a data plane description language that aims to facilitate the customization of packet processing and forwarding pipelines. And what it means is that it offers full-fledged control over how you are going to parse packets to the maintainer. And in that regard, the maintainer has the ability and flexibility to implement any protocols on demand, or you can modify existing ones and tailor them to your use. And of course, this also goes for the available telemetry pool, and it allows you to customize any measurements that can be collected from these switches. One of the applications or the idea that has emerged from the P4 organization is called inbound network telemetry. The idea behind this framework is you are going to program the data plane in a way that they recognize certain types of packets, and they can insert their own telemetry headers to those packets when they observe them. So in this figure, these packets are called probe packets, and they follow a certain sequence of switches in the network, and which is called int path. So whenever switches observe these probe packets, they will insert their own telemetry address, and this packet will grow. And when it arrives at the destination or the last switch in the path, the last switch will going to forward the telemetry packet back to the controller. So as you can see, this actually fixes one of the problems with the legacy telemetry solution, which is the communication overhead between the control application and the data plane. Since the in-band network telemetry actually allows a certain package to carry multiple information of multiple switches, so that you can actually minimize the control overhead. However, there are certain design problems in using the in-band network telemetry correctly or efficiently. So one of those problems is how many paths would you like to generate? So you can actually define any number of paths that can traverse in the network so that you can actually obtain the holistic view. However, there are certain problems. For instance, if these paths are too long, in this case, we have a 26 switches long path here from A to switch Z. If this path is actually too long, you will observe some inconsistencies in the age of telemetry information being gathered. And what it means is that these packets are stored in the network until they arrive at the controller. And therefore, when you insert the telemetry address to these packets, they will arrive at the controller after certain delay, right? And therefore, there might be some cases where if these paths are too long, the information being gathered in the earlier switches will refer to an older state of the network, while the newly gathered ones will refer to some other state. And therefore, this will create some inconsistencies for your monitoring applications. So in ideal world, you would like to minimize these inconsistencies by achieving timely delivery and using multiple paths that can cover the network. And what timely delivery means is that you would like to have paths that will arrive at the controller around at the same time, so that you can actually obtain the measurements within a certain time period in which the results will refer to the same state of the network. And also there's a problem of redundancy. And what it means is that whenever these paths intersect on certain switches, you will collect measurements of duplicate measurements in essence. However, when you do so, you are actually reducing the amount of space that you are available to you, which is maximum transmission unit that is defined over the links, right? So if you carry too much duplicate information, you will actually reduce the available telemetry space to you, and you will not be able to carry too much information, and you will not be able to provide high granularity information to your monitoring applications. So in that regard, if you minimize redundancy, you can actually maximize the amount of information or amount of different information that can be carried and fetched from each individual switch. So in our latest work, we have proposed a graph partition in-band heuristic targeting these three requirements. And those requirements are, how can we minimize the overhead, and how can we balance the path so that they can arrive at the controller around the same time, and also how can we minimize redundant information. And in that regard, we accept a certain parameter called K, which defines or sets the maximum number of paths that are going to be generated. And in this work, we generate or partition the graph in a way that we generate simple paths that contains no loops. And also they are as disjoint as possible while maintaining their balance in the layer lengths, since they correlate to how much time they will spend in the network and how fast we will deliver them to the controller. And if their lengths are similar, what we will observe is the what we can achieve is the time of delivery. And you can find more information in our latest publication that will be available later in this year. So let me briefly go over some of the important results that we have observed in this work. So essentially, as I mentioned, we have a variable called K, which defines or sets the maximum number of paths that are going to be generated by our algorithm GP. And if we set K to 2, what we are actually doing is we are generating minimum number of paths, and with 5, we are generating maximum number of paths. Regardless, what we observe is we have maximize the balance of the paths, and we are actually minimizing the length deviation of these paths, and we can achieve the final delivery. And we also compare ourselves with the other method, which was published back in 2019 in Infocom. So Edlira algorithm actually fails to generate the balanced paths, and which will cause some inconsistencies for the monitoring applications. In the right-hand side, we have how fast these algorithms can generate certain solutions that cover the whole network. What we observe is that the GPN can actually deliver the results under 2 seconds. And why it is important is that you would like to run this algorithm multiple times and probably frequently as network changes. And therefore, you would like to have a fast and efficient network monitoring framework or the in-path generator so that you can actually generate paths that can cover the network and deliver timely results. So in conclusion, in this work, we have defined 3 requirements to achieve efficient network monitoring using inbound network telemetry. And in those requirements are minimize control overhead, concurrent report delivery, and minimize redundant information. And in our latest work, we have actually improved what we have done with our heuristic, and we showed the importance of these requirements via simulations. And also during the simulation, we have observed some challenges of using inbound network telemetry and also proposed certain solutions addressing these challenges. Since it is not published, that I'm not going to go much into detail. If you ask me, I can do so in mail or in this presentation as well. So if you have any questions, please ask them. And I'm really honored to give you this presentation. And thank you so much for listening.
Thank you, Yoxel. I'm going to stop sharing now. And
yeah, hi. Can you hear me, by the way? So yes. In case. Okay, perfect.
Please let me know if you have any questions. I'm opening my chat window now. Please raise your hand as well if you want to ask something. Daniel, is your question for this presentation or for the previous?
No, this was for the previous one.
Yes.
Sorry.
Because I was sharing my screen, I didn't look at the chat, so I'm just catching up on things that people wrote.
I didn't see anything for this presentation in the chat, so just to help you.
Any feedback for Yoxel? Otherwise, I'd like to open for any questions for any of the presenters or anything else. Did you like the presentations? Did you like the session?
Yes, we did.
Thank you.
Yes, indeed, it was a very good presentation. So thank you for organizing this. So really appreciate it. Actually, I had a question. You know, you presented the website where it shows the call for funding. So I was kind of asking, yes, is it possible to look at the research topics and maybe we can apply for like one of the topics listed out there?
Yes, so I see that Hisham just posted in the chat the link for the project funding. There's two topics that we have currently listed there. Machine learning and big data analytics to the collected data, and for visualization.
Exactly, that's my question. If you look at the left side of the website, there's a research topics. If you click on it, it gives you more actually topics. So can we apply for those topics, or we need to stick to the ones listed out there?
I think the research topics that are listed on the website are things that we have collected over the years, so they're not as current maybe today, but the call is also open for other ideas. you can apply for whatever you find interesting, but these are just
maybe it's important to say that the RIPE NCC is not a government agency that has to a specific mandate in a specific year to fund something in some area. The more relevant it is for RIPE and for the ISPs and network operators, the more interesting it is for us. But you can basically suggest anything. We're very, very open. That's the difference between sort of public funding and this kind of funding. So if you have something interesting, don't feel constrained by our call for for suggestions. Yeah, just propose. Don't try to use the current buzzwords. If you use the current buzzwords, it will actually not help you.
And also, if you like, take a look at the labs article that Robert shared.
Yeah, I've seen the website. Yes, thank you. Appreciate it. Thank you.
Welcome. All right, so I don't see any other questions. So I want to thank you all for attending and for taking an active part with asking the presenters, following up on their presentations. If you're interested in presenting something next time, send me an email. I will reserve a slot for you. And yeah, so that was it from us today. Thank you for joining and see you around.
Thank you very much, Gargana. Thank you, Gargana, for once again a good job. Thank you.
Cheers.
Take
Bye.
care.
Thanks.
See you.
Bye.
Bye.
Thanks, Gargana.